Okay, let's look at another example of finding all the real zeros of a polynomial. Get a fresh piece of paper because these problems really do take like a whole page of work. Okay, but I'll take you through this example as well so you can see the step-by-step approach to solving these problems. Okay, so here is our polynomial, and take a moment to write that polynomial down. You can pause the video at any point if you need to. So the first step that we're going to follow is to figure out how many real zeros there possibly are and list out the possible rational ones. Okay, so we have up to, since it's degree 6, up to 6 real zeros. Okay, there could be less than 6, but there could be up to 6 real zeros. Let's find all the possible rational zeros. When you see that direction, you're going to want to find your p's over q's. Okay, so first of all, the p, that is all the factors of 84, plus and minus 84. Okay, so that's plus or minus 1, definitely plus or minus 2. I think I've written them all down because you can just use your calculator and take 84 and see which numbers it divides by, okay? Definitely, I think would probably want a calculator on 84. Plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 7, plus or minus 12, 14, 21, and oh, nope, not that. That's not it. 28, 42, and 84. Okay, so listed out all those possibilities for you. Now Q is literally 1, right? It's the number in front of the x to the 6th term, so that's plus or minus 1. So our possible rational zeros, P over Q, is plus or minus, and then it's this entire list, okay? So we actually could have large rational zeros over to 84 or negative 84, right? That is a lot of numbers there. Okay, so we list those out. And we know those are our possibilities. And we see that we actually, again, don't have any fractions. So if our zeros look like they're between numbers, then we know those zeros are irrational rather than rational. So that this P over Q exercise does help us a little bit in that respect. Okay, second, we're going to graph the function on the calculator. It's f of x again. And find our all our rational zeros. Okay. Okay, so here I have graphed our function for us, the x to the 6th function, and I'm looking at this graph, and I did not expand the window to negative 84 and positive 84 because it does look like the function is just right in here, and doesn't, keep going up and down, because since it's an x to the 6th, it's an even function and it's positive leading coefficient. I know it's up and up at the ends, so I think I'm seeing most of the graph. I'm not seeing this bottom part, but I don't really need that. All I need is what's on the x-axis. And what I'm seeing on the x-axis is making me wonder if I need to tighten the window a little bit so I can see. I think it's going through negative 2, and it looks like the other things are fractions or really irrational numbers, probably not fractions. So I'm going to go to window, and I'm going to tighten this up a little bit. I'm going to change it to negative 5, I think. There we go, to 5 in my x window. And then just leave your x scale as 1. And for y's, I'm just going to change it to negative 5 to 5 as well, so that I can see the graph a little better. So it's just negative 5 to 5 for x and y. So I'm kind of just zooming in a little bit. And then I can see, yeah, it does look like it touches there at -2. So maybe that -2, 0 has an even multiplicity, right? It might be, since it's just touching there and not passing through. And then the other two zeros definitely look like they are, irrational numbers, because they are not one of my lists from my list. So I'm going to draw this function, and I'm going to draw, it going through -2. Okay, so here's a little graph for us. Whee! As soon as I start graphing, I forget what the graph looks like. I don't know if that happens to any of you. Oh yeah, so it was up, and it went down, and then it touched here, and then we don't know what it does down here, but it does something, and then it comes back up. Okay, and the only rational zero was here at -2. Okay, really on my calculator, I could go through and calculate the zero like I did last time, but let me show you another way you can find a zero, especially if it's like a whole number and not a fraction. You can go to the table. Okay, and then see, my table started at x equals 0, so I need to go up and then look at that table at -2, the y does equal 0. So that's another way to confirm a 0. Okay, wonderful. So now we know that the only good rational 0 is -2, and we also know we have two other irrational zeros. So let's do the same thing that we did last time. Okay. All right, so let's write that down, that we know that that's a 0. So x is equal to -2 is the rational 0, and we know that that occurs twice, right? Because of it touching the graph right there. So in other words, the factor that we know already is x plus 2, and then it's going to be squared. It's going to have an even multiplicity there. Okay, so remember that step 3 is to use synthetic division to divide out all rational zeros or rational factors. Okay, so I'm going to put -2 on the shelf and then do synthetic division. So these are my coefficients. We do have 1 0. There was a missing term there. There's no x to the 4th term, so you have to put a 0 there. Otherwise, things will not work out well for you. Okay, we got some big numbers here, but I think it's going to work well. All right, so here's 1. Multiply, add down, multiply, add down, multiply, add down, multiply, add down. So that looks like -21. Multiply, +42. So this is -42, add down, multiply, you're getting a +84, which confirms that we did everything correctly because we got a remainder of 0. Okay, so now here is the new crazy part in this problem that you really want to pay attention to. So since x equals -2 occurred twice, that's actually 2 of our zeros. Like 1 0 is x plus 2, or one factor, and the other factor is also x plus 2. So we can divide x plus 2 out again, and we don't need to start over. We want to start with our already reduced polynomial. Okay, so here I'm just putting -2 on the shelf again, and now I'm going to restart using these coefficients. I don't bother writing that function because it's going to be an x to the 5th, and we don't need that. Who cares, right? All right, so here's 1. Go ahead through your synthetic division again. And you will, once again, get a remainder of 0. And now your polynomial is even further reduced, bringing good things to us. Okay, so now we need to rewrite the polynomial because we only had the two rational zeros. So we are stuck with this. Okay, so we started with an x to the 6th polynomial. We divided 1 0 out right here, and this would be an x to the 5th. And now we divided another 0 out, and so this is x to the 4th. So this one would be x to the 4th. There is no x to the 3rd term, so then this is minus x squared. There's no x term, and this is our constant term. Okay, so this is our reduced polynomial. It doesn't look great. You're probably not happy that it's still x to the 4th. That's why I'm doing this problem with you, because it is, a little bit of a challenging problem. So let's take a look at this polynomial, x to the 4th minus 4x squared minus 21. Let's set that equal to 0 and see what we can do. Okay, so I told you this would take a whole page, right? Okay, it's taking a whole page from me, that's for sure. So what we should think is, how can we solve this? Even though it's an x to the 4th, could we possibly factor it? Okay, and let's see if we can. So if the first term is x to the 4th, we're going to want this to be x squared and this to be x squared in order to factor and to multiply to be x to the 4th. And then 21 is our final term, so I'm just thinking 3 times 7 is really our main possibility there, because 3 times 7 is 21. And if we add those two numbers, if we make the 7 be negative and the 3 be positive, then that does add to be -4. Okay, so this does factor. So here, what we did was factor. We did not need to use the quadratic formula, which is good. Okay, so now to solve this, right, we have x squared plus 3 would equal 0, or x squared minus 7 would equal 0. Okay, now if you think about this one, if you subtract 3 here, you're going to get x squared equals -3, and this is a non-real number, right? Non-real. So in this section, you actually don't have to find that number. You can just stop right here at this factor, okay, x squared plus 3. In the next section, all we're going to do is actually find what that is with the square root of 3 of I root 3, okay? But don't worry about that now, not quite yet. We're just going to leave it because it was a non-real number. This one, x squared, when we add 7 to both sides, we get x squared is equal to 7. So when we take the square root, we get x is equal to plus or minus the square root of 7. Those are our irrational factors that we saw on the graph. The two other numbers was positive square root 7 and negative square root 7. Okay, so really we are finished with this problem, finally, right? So let's, oops, I think I went too far now. I can't see my zeros. That's good enough. Okay, so final step is to list. So here are the zeros. Okay, so first of all, we had x is equal to -2. Technically, it was -2 and -2, right? And then we have the square root of 7. We have negative square root 7. And then we have 2 non-real zeros. Okay, so you don't have to list those because we're really finding what are the real zeros in this section. Okay, but in factored form, we're still going to use that factor. So f of x is equal to, let's do the x plus 2 squared, right, from our first 0. And then we would have x minus square root 7, x plus square root 7. Okay, and then we would still have x squared plus 3. Okay, just leave that like that because we don't need to break it down further if we're factoring over the real numbers. So that's our final answer.